Dear students, in the first video lecture, we have studied the property of areas of two triangles. Let us recall A1 upon A2 is equal to B1 into H1 upon B2 into H2. That means the ratio of areas of two triangles is equal to the ratio of products of the bases and corresponding heights. From this we had derived three properties. A1 upon A2 is equal to B1 upon B2 when H1 is equal to H2. Okay. Third one, A1 upon A2 is equal to H1 upon H2 when B1 is equal to B2. And the fourth one, A1 is equal to A2 when B1 is equal to B2 and H1 is equal to H2. Even we had seen one sum based on this property, that was an extra sum. Now exercise 1.1 of your textbook is based on these four properties. Actually it is the one property, but we consider them as four different properties. So as your textbook reads, the first sum is base of a triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Find the ratio of areas of these triangles. I hope I have solved one sum, extra sum. Based on that you can solve this first sum. So all should do the first sum in your notebook, respective notebook. I am now reading the second sum. Second sum says a figure is given. I will draw the figure. In the figure, BC is perpendicular to AB and AD is perpendicular to AB. BC is 4, AD is 8. Then find area triangle ABC upon area of triangle ADB. So I am drawing the figure. You can understand the figure is given like this. There are two triangles. Okay. Two triangles are there. This is one triangle. The name of this triangle is triangle ABC. ABC, which is a right angle triangle, right angled at P. And another triangle is given this way. Is given this way. This is triangle. This is triangle ABD. This is also a right angle triangle. Now what do you notice here? You notice that both the triangles are right angle triangle having side AB common. We can consider side AB as base for triangle ABC. So same segment AB will be base for triangle ABD. That means these two triangles have equal bases. So which property will be applicable? Equal bases, this property. Okay. What is given to us? I am not writing the entire given. I am writing only for short. Okay. We are given BC equal to 4. BC equal to 4. And we are also given AD is equal to 8. AD is equal to 8. If I will mark this in the figure, BC is this side which is 4 and AD is this side which is 8. So students, just try to think. Why we have to think about the third property? Because these two triangles have same basis, equal basis, which is the base AB. AB is the base for this triangle as well as this triangle. Both are right angle triangle. Now when bases are equal, the areas of the two triangles are proportional to their corresponding heights. Okay, what we have to find? What we have to find? I will write for short F. F means we have to find area of triangle ABC, area of triangle ABC upon area of triangle ADB. So how will you write the solution for this, answer for this? In the solution we will write triangle ABC and triangle ADB have same base, that is which base? That is seg AB. Therefore, when they have same base, therefore which property we have to write? We have to write the third property. Okay, what we have to write? A1 upon A2. That means area of the first triangle upon area of the second triangle. Okay, why we have to write this way? Because this will be written as a region. So we have to write here area triangle ABC upon area triangle ADB, because we have to find this is equal to corresponding heights. H1 is height of this triangle, that is BC, and AD is the height of other triangle, that is triangle ADB. So we have to write AD, and what reason we have to write for this? Reason A1 upon A2 is equal to H1 upon H2 when B1 is equal to B2. This is the reason we should specify mathematical form. Now simply we have to put the values. BC upon AD, that is 4 upon 8, which is nothing but 1 upon 2. When you cancel it, 1s are 2s are, so 1 upon 2. So what is the final answer? Area of triangle ABC upon area of triangle ADB is equal to 1 upon 2. This is the answer. We have to put the answer in a box. This is our answer. This type of sums can be asked for 2 marks in the board examination. Okay, stopping for some time. Okay student, now we have solved this sum. Can we apply second property to solve this sum? Yes, of course. Then what is the second property? Second property says A1 upon A2 is equal to B1 upon B2 when H1 is equal to H2. That means heights of the two triangles should be equal. That means if we consider segment AB to be the height of both the triangles, then we can use the second property also. See how to write it. If AB is the height, then how will you write? Triangle ABC and triangle ADB have same height, that is segment AB. Okay, therefore, okay, area triangle ABC upon area triangle ADB is equal to BC upon AD. This will remain same, khali base only, like base will be turned into height. So same it is, but the reason will be changing. A1 upon A2 is equal to B1 upon B2 when H1 is equal to H2. Then rest of the thing is same. That means second or third, both these properties are applicable for solving this sum. Now we will go to solve the second sum. The third sum. The diagram of the third sum I am drawing. I am drawing with free hand. The diagram of the third sum. Okay, we have a triangle PQR drawn this way. P is the vertex here, Q is here, R is here. So RQ is extended. On this extended part from P, height of the triangle is drawn. PS is the height. Also we have another height on base PR. This is QT. Now we are given in the figure segment PS perpendicular to segment RQ. Segment PS perpendicular to segment RQ. RQ being extended. Also segment QT is perpendicular to segment PR. That is given. Also we have some lengths given. RQ6. RQ6. RQ is this part. PS6. PS this part. This is the height. 6. PR12. PR12 this side. This is 12. PR. Okay. Even we are given. Okay, these three lengths are given and we have to find QT. This length QT we have to find. Now think this diagram with reference to these 4 properties. we see that there is only one triangle PQR whose dimensions are given. The base is RQ6 and the height is PS6. Base and height. For the same triangle PQR, base PR is there, which is 12, and height QT. So what we will do is we will find first the area of triangle PQR. But what we have to find? We have to find here length of segment QT. Find QT. They have given find length of segment QT. This we have to find. So how will you solve? In the solution, first we will write area of triangle PQR is equal to half into base into height. So we will find half into base. We will consider RQ as the base, and height we will consider PS, because the base is considered as RQ. So height will be drawn from this. This is an obtuse angle triangle. So base has to be extended for drawing the height. Now values are given. Half into RQ is 6 and PS is also 6. We can cut this. Okay, 2 3s are 6. So 18 square units is the area of the triangle PQR. Now this we will use for finding area of the same triangle, area triangle PQR. Why I am writing area of triangle PQR again? Half into base into height. Why? Because I will use the value of area of the triangle. Therefore 18, and different base and different height I will use. The base I will use is segment PR, and the height drawn on segment PR, side PR is QT. Okay, now substituting the value of PR, 18. Why? Because we got in the first step. 18 is equal to half into PR is given to be equal to 12 into QT. So we can cut this. 2 6 are 12. Now 6 will shift to this side. 18 divided by 6 is equal to QT. Therefore how much is QT? QT is equal to 3. Okay, this is our solution. So we can find, but we have not applied any of these three properties. Okay, can we apply any of the three properties? Yes, we can apply. Think which property we can apply. We can apply the first property. How? See, I will write like this. First property can be written like this: area of triangle PQR upon area of triangle PQR is equal to base into height. Which base we are taking? RQ into what is the height on the base RQ? PS upon same triangle now, but the different base we have to take. PR is the base and height will be QT. Then why didn't we use this property and we solved by using formula method? We can use. We are a little bit confused. Why? Because we have to write same triangle again and again, but no matter, we can do this. Okay, what is the reason for this? A1 upon A2 is equal to B1 into H1 upon B2 into H2. Little bit congestion is there. You can understand the reason we should write. Now we know that since they are areas of the same triangle, this is cancelable. So here result is 1. If they are cancelled, result is 1. Now let us put the values. RQ is 6, PS we are given 6, upon PR is given 12, and QT is to be found out. So we write QT. Okay. Now 1 is equal to 1 multiplied by this 12 into QT is, because cross multiplication, or we bring 12 into QT to this side. So we have 12 into QT is equal to 6 into 6 is 36. So how to find QT? QT is equal to 36 divided by 12. 12 will be dividing 36. So QT is equal to 3 units. So even if you want to use the properties that we have studied, we can use the first property and solve the sum. Understood? So we will take a halt and go for the next sum. Dear student, here is the fourth sum. I have already drawn the figure. They are saying that line AD is parallel to line BC. Line AD is parallel to line BC, and segment AP perpendicular to segment BC. AP is perpendicular to segment BC or line BC. We have to find area triangle ABC ratio area triangle BCD. Area triangle ABC ratio area triangle BCD. Now observe the figure carefully. What is given here? You see two triangles, triangle ABC and triangle BCD. Okay, both the triangles are on the same base. Segment BC is the base. And even you see that both the triangles lie between the same parallel line. The triangles lie between the same parallel line. Triangle ABC is an acute angle triangle and triangle BCD is an obtuse angle triangle. You can see little bit slant here, more than 90 degree. So it is an obtuse angle triangle. But both the triangles have same base and they lie between same parallel lines, so their heights will also be equal. Why the heights are equal? Because if AP is the height of triangle ABC, height of triangle BCD will be drawn from vertex D and it is the perpendicular segment. And you know, this segment and this segment will be of the same length. Why? Because the distance between parallel lines is same at every place. So what we have to ultimately conclude, these triangles have same base and same height. So which property we will use? Either this property or we can use this property. Okay, how will you write the solution? How will you write the solution? We see the two triangles, triangle ABC and triangle ABC and triangle BCD. Triangle BCD have same base. Which base is same? Same base, that is we have to mention, that is segment BC, and they have same height. They have same height. Why they have same height? Why they have same height? Because they lie between the same parallel line. As they lie, okay, between same parallel lines. Between same parallel lines. Parallel lines. Therefore, what we have to write? Therefore, area of triangle ABC is equal to area of triangle BCD. Why? What we have to write? The fourth property. Right? Reason we have to write A1 is equal to A2 when B1 is equal to B2 and H1 is equal to H2. Simply the fourth property. Therefore, we have to find the ratio of the areas. Therefore, area of triangle ABC upon area of triangle BCD is equal to 1 upon 1. Why? Because they have same area. So, we can cancel them. So, it is 1 upon 1, that is 1. Therefore, what you would write? Therefore, area triangle ABC ratio area triangle BCD is equal to 1:1. This is our answer. This is our answer. We can even use the first property and solve this sum. Okay. So please try using the first property and solve. Answer would be the same, of course. There is no difference in the answer. Answer would be same. And even you know that all these three properties, second, third and fourth, which we have derived, actually they are derived from the first property. So even we can use the first property to solve this. Please try to solve this sum using the first property, and then we will move for the next sum, that is sum number 5. Okay student, we have the fifth sum. The diagram is given. Triangle ABC is the big triangle that you see. Triangle PBC is another triangle that you see. And we are given that segment PQ is perpendicular to side BC and segment AD is given perpendicular to side BC. And we have to find the ratio of areas of various triangles. Now let us see the first ratio. What does the first ratio say? We have to find area triangle PQB ratio area triangle PBC. PQB is this triangle and PBC is this triangle. Do you notice, children? Do you notice what is equal? Do they have same height or same base? In triangle PQB, if you see, if you consider BQ as the base, then height is PQ because this is a right angle triangle. And in triangle PBC that you are seeing, if you consider BC as the base, then PQ is the height. So you see that height PQ is same in both the triangle. Now when height is same, we have to immediately think about the second property. A1 by A2 is equal to B1 by B2. So what I will write in the solution? I will write first triangle. Which triangle? Triangle PQB and triangle, which is the other triangle? Triangle PBC. What do they have? Do they have same height or same base? They have same height. So triangle PQB and triangle PBC have same height. And which is the height that you have to specify? Same height. Which is the same height? That is seg PQ, which is the height, right, for both the triangles. Therefore, area of triangle PQB upon area of triangle PBC is equal to, when heights are same for both the triangle, the areas are proportional to corresponding bases. What is the base in triangle PQB? BQ. BQ is the base. I write BQ. And what is the base of triangle PBC? BC. BC is the base. So now this will be our answer. Why? Because no values are given. No values are given. Only we are supposed to find ratio of the areas of the two triangles, and we already got it. If they would have given you the value of this lengths of these segments, then we would find further. But this is ending here. Why? Because the values of BC and BQ are not given. This is our first answer. Second part you are seeing, area triangle PBC ratio area triangle ABC. That is what we have to find. Find out where is triangle PBC. Triangle PBC is this triangle where BC is the base and PQ is the height. And triangle ABC. In triangle ABC you are seeing that BC is the base and AD is the height. Now what is same? Base BC is same in both the triangles. So when base is same, we go for the application of third property. So what I have to write in the second, part of the answer, we have to write that triangle PBC and triangle, which triangle? ABC have same base. Which is the same base? Same base, that is segment BC. Therefore what we have to write? Therefore we have to write area triangle PBC upon area triangle ABC is equal to, when the bases are same, areas are proportional to corresponding height. What is height of triangle PBC? BC is the base, PQ, it is PQ. And what is the height of triangle ABC? When BC is the base, it is AD. So this is our answer. Area triangle PBC upon area triangle ABC is equal to PQ upon AD. We have to specify the reason. Of course, we have not even specified the reason here. Here the reason would be of this one, equal heights. So we have to write A1 upon A2 is equal to B1 upon B2 when H1 is equal to H2. And here in this part, what you have to write? A1 upon A2 is equal to H1 upon H2 when bases are equal. B1 is equal to B2. So the two sums we have done in this fifth sum. Okay, two more are there. Area triangle ABC. See that area triangle ABC. BC is the base, AD is the height. Area triangle ADC. Area triangle ADC. BC is the base and AD is the height. Now you are smart enough to understand what is same in both of them. Okay, and accordingly you will apply the property, the respective property, whichever is fitting with this, and you will solve. And the fourth one, area triangle ADC. ADC is this small triangle here, and area triangle PQC. PQC, you are seeing this PQC. Now ADC has DC as the base and AD is the height. PQC has QC as the base and PQ as the height. Now both the triangles have different base and different height. That's why we use the first property. So I hope third and fourth part of this sum you will try yourself. Okay, and this will be the last sum. This is the last sum of the exercise 1.1. I think so. Yeah, this is the last sum. After this, we are going to study a very, very important theorem, which is called as the basic proportionality theorem. Very popular in SSC students, among SSC students, SBPT. It is basic proportionality theorem. Very important theorem it is. We will study this theorem in the third video lecture, and as I have shown you how to solve all the 5 sums of exercise 1.1, you must try them at home. And in addition to this, in the next part here in the same video lecture, I am giving you few extra sums which you will solve yourself. Keep them ready and always develop a proper habit of writing systematic answer. Okay, we have to write, answers must be boxed, proper reasoning must be there beside every step. Okay, that will be very good habit. It will be very very helpful to score higher marks in your SSC exam. Now I am giving you some extra sums which you will practice. So students, I have written one extra sum. It reads like this: the ratio of areas of two triangles with equal bases is 3:5. The height of bigger triangle is 15 centimeter. Find the corresponding height of smaller triangle. So just write down. I am just showing you how to do it, and I will give you extra sum. What do we have? We have A1 ratio A2 is equal to 3:5. Also we have, they have equal bases. Triangles have equal bases. So B1 is equal to B2, that we don't write, it is understood. Heights are given, height of bigger triangle. Now how will you judge which triangle is bigger? A1 is bigger or A2 is bigger? See the numbers of the ratio, 3:5. 5 is bigger number, so A2 must be a bigger triangle. If A2 is a bigger triangle, then H2 will be bigger height of the bigger triangle. So height of bigger triangle is 15 centimeters. So what is this 15 centimeter? It is H2. So H1 we have to find. H1 is question mark. We are given H2, that is equal to 15 centimeter, and we also have B1 is equal to B2. Understand? So what you have to write? Since the triangles have equal bases, their areas are proportional to the corresponding heights. Okay, that is our property. Which property we write? A1 upon A2, that is A1 upon A2 is equal to H1 upon H2 when B1 is equal to B2. Okay, so A1 upon A2, the ratio is given 3/5 is equal to H1 we have to find upon H2 is 15. So how will you write? Cross multiply, 3 into 15 is equal to H1 is into 5. So how to find H1? 3 into 15 upon 5 is equal to H1 this 5 is brought here, 5 3s are 15. Okay, so H1 is equal to 9 centimeter. Therefore the height of which triangle? Smaller triangle. Height of smaller triangle is how much? Is 9 centimeter. Understand? This is our answer. Okay, have we written the reason? Yeah, we have written the reason, everything. So this is how we have to solve the sum. Now I am giving you extra sums. Use your brain and try to solve all these sums. Okay, thank you. Yes, student. Now these are the extra sums I have given. Kindly solve them. Steal your screen, copy down the question and try to solve. Use your brain. Don't get distracted. Don't get less confident, because all the sums are based on the properties we have already studied, and I hope you will be able to do it. Best of luck. Please solve. Keep yourself busy. Stay at your home. Do not go out. Take care of your health.